Welcome sports fans to another exciting episode. Today, on easily one of the hottest and most humid days of the summer so far, we're working on the cabin heating system. Now, part of this kind of thing is that when you go to retrofit parts after completing the conversion, it tends to give you a couple of problems because you've put stuff in the way of an ideal spot, you know, of where you're going to be putting something, and it's an unfortunate side effect of actually having to drive the car as well as convert the thing. So what I've been doing so far is I've been just rerouting some hoses for the controller cooling system and looking for a spot to put the heater tank. Now, one of the things that I neglected to mention in the heater tank video was that it has to stay vertical, and that can be a bit of a challenge when we're looking for a space to put the thing. But we did find somewhere. It's quite a neat spot, so stay with us and we'll run through that. So as usual with these projects, we need to remove some of the former bits to make space. And here comes the space, if we can see it. That is, if I keep doing a Blair Witch on it. Going in. And there we go. That's where all of that plastic lived. So by getting rid of all of that plastic, we were able to find a nice spot there where we can put the heater tank. And here is our heater tank sitting in its new location. Some of you may have noticed that I've had to remove the pump to make it fit in here, but we can mount the pump pretty much anywhere that we choose. So I'm going to go ahead and get this bracketed in, and we'll come back when we're starting to find somewhere to put the pump and run some hose. Stay with us. Alrighty folks, so this is our heater mounted. I sealed up those terminals on there on the traction side with some tiger seal. And we're just about to hook up our hoses. For this job we're using a Goodyear 16mm heater hose. And this bend here that we have to make to connect to the inlet is going to be quite acute. So just a quick little tip. Although the hose might not kink now when it's at ambient temperature, when the fluid heats up, if we have a tight radius on it, the possibility is that the hose could actually collapse in and kink on us. So to help prevent that, we're going to use a particular type of a spring. This little spring here is actually designed to fit inside the hose diameter. Just literally stuff it in there, and we just stuff that down to the point where we want to make our bend, and it'll prevent the hose wall from collapsing in. Very good source for those are LPG conversion shops, and they actually have this nice bracketry material here that I've used for mounting the tank, and very easy and nice stuff to work with. So I'm going to go ahead, plumb some more of this stuff up. Not going to expose you guys to every single connection, but we'll do our run through when we've got all the plumbing sorted. Stay with us. Alrighty folks, so we're getting to the point that we need to make some connections to the heater matrix. But before we actually connect our new heating system up, it's kind of important that we perform a particular task known as flushing the core. Well, it sounds like something out of a sci-fi film, but What it basically means is that I've connected my garden hose up to the heater backwards, so I have the hose water going into the outlet, which would normally be the outlet, which is on this hose, and I have my outlet on this hose, which is just going down to a drain here. So I'm going to bring you guys over and let you look down the drain. Bound to be exciting. See if we can get a better view on the drain for you. There we go. So this is our outlet hose, and what my concern is that this car hadn't really been looked after too well, and it had a definite cooling system problem, and it was running on tap water for a long time. And as well as that, now the engine has been out of the car for over a year, so that heater matrix has been exposed to fresh air, and so we've probably got a lot of nasty crud in there. So I'm going to just very gently turn on the tap, and we'll see what the hell happens. Hopefully no unexpected flows. Got my tap turned on. Oh, here we go. Oh, not too dirty at all by the looks of it. Got some nice flow coming out of that. But I'm going to let that run for a couple of minutes just to flush out anything that shouldn't be there. But so far, I have to say, got a nice flow through it, and it doesn't look like there's any real garbage in there, so might well be a waste of time doing this, but I still feel a little bit safer to know that we've flushed it through for any nasties. Okay guys, we're back with our E39 heater. So I'm in the process of wiring up our fluid heater and pump and various other bits, and I'll be running through all of that stuff later, but what I wanted to try to work out was a means to control it. Now the most obvious way to do that is just to put a toggle switch on the dash somewhere. You just turn on the blower, flip the switch, heater comes on, and we're all set. But what I wanted to try to do was to try to see if I could utilize an existing signal. Now, on most BMWs, the heater matrix is always part of the airflow. So some cars use flaps that direct air to bypass the heater matrix for cooler air, or to go more so through the heater matrix for warmer air, and coolant always passes through the matrix regardless of what the heater control settings are at. But these cars do it a little bit differently. There is a valve here. It's not very exciting. It's just a simple on-off solenoid valve in series with the heater matrix. Now in our system here, we've completely bypassed it and just gone into the matrix from our fluid heater. Now there's a 12 volt signal feeds to that valve, and depending on the settings of the climate control, the ECU determines whether to have the valve open or closed. Now it looks to be that these use an inverted logic, i.e. when there's no power being supplied, the valve is fully open, and when there's 12 volts being supplied, the valve is fully closed. And it looks to also modulate that in a kind of an on-off cycle, depending upon the settings of the climate control. So just to try to figure some of this stuff out, I've connected a little 12 volt MES lamp up to the wire plug that I've disconnected from the heater control valve. So what I'm going to do, I hope you guys will be able to see this because rather bright sunlight today. Let me see if I can, whoops, there we go. Should be able to see that little lamp just on top of the multimeter. I'm going to turn the ignition on and run through some of the settings on the climate control. So we're basically starting off with our heater set, let's say to full cold, our fan turned off. So I'm going to go ignition on. So as soon as I find the key. So that's ignition on. As you can see, our lamp is on. Now, it doesn't matter what I do to the heat setting at this stage, it doesn't affect the lamp. So I'm going to turn the blower on just on low speed with the, again, temperature set to full cold. And again, as you can see, with the temperature set to full cold, the lamp stays on. Now, according to my temperature gauge in the car, it's about 22.5 degrees centigrade air temperature today. So I'm going to dial my climate control just up to around 22, 23 degrees and we'll see what happens. Just coming up on 22 now. We're about 22 or 23 degrees. As you can see, the lamp is starting to pulse. And this would be basically in response to the cabin temperature sensor calling for basically heat from the coolant. And if we go to full hot, the lamp stays off. And if we go back to full cold, the lamp comes on, and back to full hot, lamp goes off. Now, interestingly, if we're on full hot, when we turn off the fan, lamp goes off, or sorry, goes on to turn off the heat. If I turn on the fan again, lamp goes back on. Turn off the fan, we go back. So, alrighty folks, we've got our heater installed and wired up both on the high voltage and on the 12 volt side. So before we do a test, I thought I'd just quickly run through the control scheme and so forth that we came up with. So first of all, let's have a look at how our high voltage wiring worked out. Get you guys in here a bit closer. So right down here, probably can't see it too well, but we have the actual heater. We have our high voltage wiring in this piece of orange conduit going into an existing distribution box here. So let's have a look inside. Now, most of the bits in here are to do with charging and mains input, but I had some space here and it kind of worked out handy that I could put the components in here. So firstly, what we have is we have a 32mm fuse holder and a 30 amp 600 volt DC rated fuse in here, and that takes battery power from our traction system. That power comes out of the fuse holder, goes through a kilovac EV200 contactor, comes out of that and goes into the positive of our heater. Heater negative connects to battery negative, and our earth connection just connects to mains earth. And that's the high voltage side of our heater system. Strictly speaking, you probably don't need to have that contactor there, but I just want to be sure that the heater can't come on when it really shouldn't, and that I have the power isolated to it at all times when I have the key turned off, and that is the purpose of that contactor there. So next part then that we needed to work on was how to actually control the heater. Now, you may recall from the last segment that we did that we had a little test lamp rigged up onto the wiring that was going to our heater control valve, and we found that when the car was calling for heat, that it de-energized the test lamp, and when it wanted to turn off the heat, it energized it with 12 volts. So in order to devise a control system, did a little bit of thinking, and I came up with something quite simple. Here we have two traditional 12 volt automotive relays. The black one is a single pole changeover contact type, and the blue one is a single pole normally open. Now the black one is got its coil connected to the very same cables that previously fed the heater control valve. So when the car thinks that it's controlling the heater control valve, it's just energizing or de-energizing the coil in this relay. I have then used the normally closed contact of this relay to provide the ground for the coil of the blue one, and the positive coil feed for the blue relay comes from a switched source that I have here that only goes to a power on state when the key has been turned to the start position, so when I want to drive the car. So when my systems power up, things like the motor controller and the brake pump and the cooling pump for the controller and all of that kind of thing, when they get a power on signal, that same 12 volts is available to energize this relay here on the positive coil side. Now if we have our heater turned off, this relay is in fact energized, and thus removes the ground from the coil of this relay here, which controls a 12 volt feed that provides 12 volts to the heater signal input, the pump which is under here, and the kilovac contactor. So when our heater is turned off, we have no coil ground for this relay, and it's not energized, so we have no power going to our heating system. Nor do we have power going to our heating system now, even though this relay is de-energized, because the 12 volt feed is, as I explained, only available when the car is fully turned on. So additionally, when the car is on charge and the rear pack contactor is closed, this contactor here basically ensures that we're not supplying power from the traction system to our heater. I would be a little bit nervous about leaving it connected to the traction source permanently. I would feel that a malfunction in the control circuit in here could easily leave the heater being turned on fully, permanently, and at night when there'd be nobody paying attention, with fairly predictable results. So this contactor provides a little bit of a safety feature in that regard. So this is how our 12-volt control system operates, and it's quite neat because it lets me use the existing dashboard controls to basically control the hot and cold air source for our cabin heat. So we'll be going through that now shortly. Oh, well, that's for good luck. Wow, looks like one of my avian assistants made a donation, which fortunately missed the control system, but just splattered here onto this area of the mounting bracket. So, well, okay then. Right, after that interlude, as I was saying, our 12-volt control system here is quite neat because it lets me use the existing heater controls inside the car, so I didn't have to go mounting a switch or so forth. So that's quite a nice touch. So why don't I wrap this part up, and we'll get inside the car and we'll get the thermocouple set up, and we'll start heating things up. Stay with us.